Good morning, children. Welcome back to your chemistry class. So today we are going to begin with a new chapter, that is polymers. Okay, so in our daily routine we come across many of our useful things such as say rubber, plastic, fibers and carbohydrates, protein, your wool, your silk, polyester. So some of these things, they are provided by the nature. As such, while most of these things, they are prepared from the natural resources by different people of different skills, right? For a common person, what is rubber? It means just a material that is used maybe in the tires, or the plastic, it means the material which is used in the manufacture of the buttons or buckets or some compact disc, CDs, radio, TV cabinet, all these things. So this is correct, but what chemists think about rubber? What do the chemists think about plastic, wool? That is different. So from the chemist's point of view, these materials, they are termed as polymers. Okay, then what are polymers? What the type of polymers, what are the uses, is all that we have to study in this chapter. So before we study about the different types of polymers, let us first understand some important terms that we are going to use in this chapter. Okay, so the first word itself, polymer. What does this word polymer mean? Okay, it is a big molecule which is made up of many smaller molecules bonded together. That is called as a polymer. Poly, it is made up of actually two words, poly and mer. Poly means many and mer means units. Okay, so if we combine the two words, we get this word polymer. So a big molecule, a big molecule which is made up of smaller molecules bonded together is called polymer. Clear? So we can take some examples over here, like polythene, as the word suggests, and you have also read about it earlier. It is composed of thousands of ethene units bonded together, isn't it? For example, n types of CH2 bonds are found over here. So I can draw it like this. This is infinite, okay? CH2, 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 CH2 and so on. So in a compact form, this polythene, how is it written? It is written like this, where N is what? The large integer. The polymers having very large molar mass, they are termed as high polymers or macromolecules. What are they also termed as? Macromolecules. The molar mass of macromolecules, what is their range? It is the molar mass of these, it is around 10 to the power 3 to 10 to the power 6 grams per mole. Okay, so they are huge molecules. Now let us come across another word, that is monomer. Monomer. Okay, so what is monomer? Now as the word suggests, mono means one. Okay, the smallest unit of a polymer, therefore it is called as a monomer. The smallest unit of a polymer is called as a monomer, right? In polythene, what is the smallest repeating unit? The smallest repeating unit in polythene is your CH2. So this is going to be called as a monomer, right? Which in isolation, it is just a molecule of what? Ethene. Simple. It can be written like this also, CH2 double bond CH2. So ethene molecule, it is the monomer of the polythene polymer. That is, mono word means one and unit is mer. This is what I have showed you. So this ethene, its monomer is this and its polymer is this. Okay. Next we move to dimer. Dimer means where, as the word says, di means 2 units of a polymer when they are present there, then it is a dimer. Okay. Then it can also be a trimer and so on. I hope you have understood all these things. Now next word that I am going to come across is polymerization. Polymerization. What is polymerization? The process of formation of a polymer from its constituent monomers, it is called as polymerization. Okay. So the process of formation of a polymer from the constituent monomer is called what? It is called as polymerization. Clear? Like for example, N CH2 CH2. Right? What is this? This is a monomer. Right? When polymerization takes place. It is a process, no? Polymerization takes place, the process of formation of the polymer from the constituent monomer. When number of monomers, when they undergo polymerization, it is going to form the polymer of what? CH2, CH2. This is on till N. Thus, the polymerization, it requires various conditions of temperature, pressure, then the initiator is also required, catalyst is also required, then only the polymerization takes place. Next word we come across is Homo Polymer. Now what is Homo Polymer? A polymer made up of identical repeating unit. It is called as Homo Polymer. Homo means what? Identical. Polymer, you have already understood. Okay. So a polymer made up of identical repeating units. Polymer made of identical repeating units, they are termed as homopolymer. The arrangement of monomers may be different for polymer or to polymer. Therefore, homopolymer may have a linear structure, it can have a side branching, or it can have a cross link also. So it depends. So this is termed as homopolymer. Then we come across copolymer. What does co word mean? Co means cooperation. Okay. So cooperative means, co means cooperative. So a polymer made up of two types of monomeric unit, it is called as copolymer. For example, polymerization of styrene and butadiene, right? Together it gives a copolymer. Unit which is known as SBR. What is that SBR? That is styrene butadiene rubber, and it is a synthetic rubber. So let me explain it to you over here. So co, as I word said, means cooperative. So when two or more monomers, they are cooperative and they combine to form a polymer, then they are called as copolymers. So the first example that I gave you was that of SBR. What is SBR? It is styrene butadiene rubber. Okay, so let us understand how is it made up of. As the word suggests, it is made up of styrene. Okay, sorry, plus it is made up of butadiene. So let's look at the structure. Butadiene is what? 2CH2 double bond CH double bond CH2. What is this? This is butadiene, right? This combines with styrene. Now styrene is what? It is CH2 double bond CH C6H5. What is this? This is styrene. It combines with another butadiene, that is CH2 double bond CH double bond CH2. This is another butadiene. So two monomers of butadiene and one of styrene, that is the cooperative polymer, right? They combine to form what? They combine to form SBR, styrene butadiene rubber. So if we bring all of these together, so what is the structure that will be formed over here? It will be CH2CH double bond CH2. This will go on. This is 2 times because butadiene is 2. Then this will be further combining with CH2CH C6H5. Then CH2CH double bond CH2 and so on. So what is this? This is a copolymer unit of SBR. A copolymer unit of SBR. Okay. Another example you can take, like Nylon 66. These are important polymers. Okay. It is a polymer in which there is a repeat unit, and it is a copolymer of two types of monomers again. What are those two types of monomers? It is made up of hexamethylene diamine, okay, and it is also made up of adipic acid. So I'll show it to you just now. So nylon 66, it is what made up of hexamethylene diamine. So let's see what is so let us see what is hexamethylene diamine over here. H2N CH2 whole 6 NH2. What is this? This is your hexamethylene diamine. Okay, it combines with your adipic acid. Now what is adipic acid? It's C, then this becomes CH2 for COOH. Okay, and what is this going to give? In fact, let me write it down like this. It will be better. So what is it going to give? It is going to give you the copolymer of nylon 66. So let us see what is the copolymer of nylon 66. It is dash dash NH. Okay, then CH2 6 NHCO CH2 4 CO and so on. This is your nylon 66 copolymer. So when large number of such copolymer units they repeat, then what will be formed? A macromolecule of nylon 66 will be formed. So we give the number to it, that is 66. Double of 6. It indicates that each monomer molecule has how much? 6 carbon atoms. I hope this is very clear to you. Now next we come to degree of polymerization. Degree of polymerization. Okay, so the number of monomers which constitute a molecule of a polymer, that is called as the degree of polymerization. Like for example, in dimer the number of monomers are how many? 2. In trimer there are 3. So the number of monomers is 3, but in polymer the number of monomer is always very large. Sometimes it is even in the order of 10 to the power 3 to even 10 to the power 6 or even more. So degree of polymerization, how can it be given? It is always given with this formula. molar mass of the polymer, right, upon the molar mass of repeat unit. This is how we find out the degree of polymerization. Now next we come to classification of polymers. I will not go into deep classification of polymers in this video. In the next video I will start with the deep classification of polymers. Over here just the rough idea of how the polymers are classified. So let us start with the basis of classification of polymers. Okay, so over here for the systematic investigation of the properties and the uses of the polymers, they have been classified into how many types? 4 types basically. So let me explain it to you. So on the basis of the occurrence, right, the polymers, they have been classified as what? According to the sources, they have been classified as whether they are natural or they are synthetic or even semi-synthetic. About all this we are going to study in the next video. Then based on the structure, they are classified as linear or maybe branched chain. Okay, then they can be also cross-linked or maybe the network kind, that we will study later. Then they can also be again classified on the basis of the mode of polymerization. Mode of polymerization. How? They can be like show addition polymerization or even condensation. Okay, then the nature of predominant intermolecular force of attraction, an important property. These polymers, they have been classified as elastomers or fibers or thermoplastics or thermosetting. That is the 4th kind, that is based on the molecular forces. Okay, they can be classified as elastomers, then as fibers, then they can be classified as thermoplastic or thermosetting. Okay, so about all this we are going to study in the next video. Till here today, thank you.